Hi everyone. Today we're going to talk about Notional wrapped fCash. Wrapped fCash is a compatibility layer for developers who want to integrate with Notional lending, but are unable to use the ERC1155 standard. So wrapped fCash works with ERC20, ERC777, and the newer ERC4626. We'll get into the kind of mechanics of what how wrapped fCash works, but quickly, I want to first review what fCash is and how Notional works at a high level. So we have documentation here at docs.notionalfinance/notionalv2. And fCash is sort of the building block of the Notional system. So Notional is a fixed rate lending and borrowing platform. And when you lend and borrow at a fixed rate, the token we issue you is called fCash. So for example, DAI that matures on December 1st, 2021 is redeemable for one DAI at maturity. fCash tokens can be positive or negative. Positive fCash balances is equivalent to lending. And in this code base that we're reviewing today, we will exclusively be working with lending balances. On the flip side, there are negative fCash balances that represent debts. Now, debts are not sort of less fungible than lending. So, and in this wrapper, we do not deal with debts at all. The settlement and kind of denomination mechanics will come into play here. So this is important to understand. fCash is denominated in an underlying token like DAI or USDC. So when we say that you have one fDAI, that means that you have a claim on one DAI at maturity. So all fCash is denominated in a combination of currency and maturity date. So December 1st, 2021 fDAI is fungible with other December 1st, 2021 fDAI, but not fungible with, say, March 1st, 2022 fDAI, because that matures on a different date. When fCash settles, what it does is it settles to CDAI. It settles to a money market token like CDAI or ADAI. In Notional right now, we use CDAI. What that means is once the DAI matures, we store a settlement exchange rate between DAI and CDAI inside of Notional that happens globally for all fCash of a particular maturity. And the fDAI is now redeemable for an amount of CDAI that represents 100 DAI at maturity. Going forward, that fDAI or that matured DAI will start to accrue the money market C token interest rate going forward. So therefore, the user is not left with the user is not missing out on any interest after maturity. So this fCash page is probably good to review and understand before you dive into the code, just to get a better understanding of fCash mechanics. Now we'll talk a little bit about how wrapped fCash works. So each wrapped fCash contract is going to be deployed from the wrapped fCash factory. Once that's deployed, you will have one wrapped fCash contract per currency maturity combination. So that'll ensure that each fungible fCash asset has one canonical kind of address associated with it. And everyone who's interacting with it can transfer to and sort of interact with each other. These are using OpenZeppelin beacon proxies underneath. So what that means is there's a singular wrapped fCash ERC4626 contract that's sort of the implementation, and that can be upgraded by the owner to add functionality or make changes in the future. And then each wrapped fCache instance is going to be a beacon proxy that points to that implementation. So each beacon proxy has its own storage, but its implementation is at this beacon implementation here. So there are two primary things that you can do with wrapped fCache. You can lend. So that's essentially minting wrapped fCache tokens. There are sort of 4 ways to do this, and we'll talk about how they work. And then there's sort of a more kind of technical way to do this through ERC777 transfers. We'll also show you that. And this is the kind of most gas efficient way to mint wrapped fCache. The caveat here is that when you mint wrapped fCache, you sort of relinquish the ability to borrow against it as a collateral asset. So natively inside Notional, any lending positions that you have are automatically considered collateral for future borrowing. So for example, you could lend fCache, you can lend a million fDAI at 6 months, and you can borrow a significant amount of DAI against that at a different maturity, like a 3-month or a 1 year. So, but however, by interacting with wrapped fCache here, you're going to lose that ability because it's going to be held in escrow on the wrapped fCache contract. This is not going to be a concern for most users. The target user base here is going to be sort of lending only integrations with Notional. And the goal here is to make that a lot simpler. Redemption. So wrapped fCache can be redeemed anytime before or after maturity. When you redeem fCache prior to maturity, what you're going to be doing is selling that fCache on the Notional AMM for cash. So that is subject to prevailing market interest rates, and also sort of the time remaining until maturity for fCache. So in that situation, the user will not be necessarily like receiving that fixed interest that they were promised. They'll be receiving some other interest rate based on prevailing exchange rates. When you hold to maturity, that kind of dynamic that we discussed earlier with the settlement to a money market token and then sort of accruing the money market interest rate thereafter is what will occur. So leaving your wrapped fCache inside the wrapper for a little bit is not going to lose you any interest. So here's some stats about the code. Just to kind of quickly review here. So the proxy code will sort of handle the deployment mechanics, and we'll take a look at that first since it's not too involved. These libraries are pulled basically from the Notional smart contracts, like kind of core smart contract base. We'll review them quickly. There's not too much logic here. And then we'll talk about the wrapped fCache base, which implements sort of I would say like a lot of the view methods and some of the kind of more benign kind of integrations with Notional. Then we'll look at fCache logic, which implements a lot of the lending and kind of like redeeming logic, sort of the business logic associated with interacting with Notional and like establishing these positions. And then finally, we'll look at the ERC4626 implementation, which is sort of a lot simpler since it mainly uses the wrapped fCache logic that we have. So let's take a look at these proxy contracts first. Quickly, the end beacon proxy and the end upgradable proxy are simply imports from the OpenZeppelin implementations, and here we add a receive ether method, and this is really just to import the contracts into Brownie so that we have access to it. The wrapped fCache factory. So this will be deployed as a standalone contract. And it will point to the upgradable beacon. and users or developers can call the deploy wrapper compute address methods here. So this is using the OpenZeppelin create 2 implementation. If the contract is deployed, it'll just return the address for you. If not, it will go ahead and deploy that wrapper for you. The wrapper is going to be the NBeacon proxy. So that's a thin proxy, and it'll be initialized with the currency ID and maturity combination, which identifies the fCash. So currency ID is going to be like an auto incrementing integer that's defined on the notional side that maps to ETH, DAI, USDC, and WBTC. And maturity here is going to be the Unix timestamp of the time when the fCash is going to mature. So this is the factory contract, fairly simple. Constants, a lot of this is just sort of date math and sort of internal things that Notional recognizes. The date time contract here, I won't go into this in depth, but this is essentially like kind of the date math that Notional uses to determine different markets and sort of when different maturities and how they are identified in the system. Encoding and decoding. So there's some like byte kind of level encoding for ERC777 IDs and trade actions. So that's sort of handled in this library. Again, there's not too much to see here, but we'll kind of review this. And these are the enums and structs that are sort of required to interact with Notional. So that we would use in this contract. So now we'll start looking with the wrapped fCash base contract. So the wrapped fCash base contract, now remember again, this is going to be an upgradable beacon implementation contract. So we have two sort of quote unquote like initialization functions here. One is the constructor, which sets the two immutable addresses that the implementation will hold, which is the address of the Notional like proxy, the primary Notional proxy, where all the lending and borrowing is going to occur, and then WETH, which we use as a compatibility layer for interacting with lending and borrowing ETH. So that's set up on the constructor, and we have this initializer modifier here to ensure that the implementation is initialized and people can't attack the contract by initializing the implementation and things like that. In the initialize function, what we'll do is we'll set this fCash ID storage slabs. This is going to, once it's set this on initialization, that'll sort of identify which currency ID maturity combination this wrapper is interacting with. So some of that is going, some of that logic here is here. So the things we'll ensure is that, we'll go get the cash group off Notional. This tells us that this is actually a currency that can be lent or borrowed if the max market index is greater than 0. We'll also check that this is a valid maturity so that it falls on sort of the maturity cadence that we allow for trading on. Once we get that, we'll encode the assets, and then we'll get the underlying token and asset token. So the underlying token will be like DAI, USDC, WBTC, etc. The asset token here refers to the money market token that fCash settles to. So that will be CUSDC, CDAI, CETH, C tokens essentially. We set up the names here. So this here is going to be like wrapped f DAI at, and then this this maturity will be the number referring to the Unix timestamp of the maturity. So here note that we're using the ERC777 standard, so that incorporates the ERC20 standard and adds some other sort of like methods. We do this just to open up the range of compatibility for wrapped fCache. So here we're going to allow Notional to interact with the contract and pull asset tokens and underlying tokens if it needs to, as it does lending and borrowing. The rest of these methods here are just going to be sort of view methods. Kind of important to note here is that decimals. So fCache is always denominated in 8 decimal places, regardless of the underlying denomination. So this is kind of similar to C tokens. And so there will be some decimal conversion like in and out of that 8 decimal precision there. So here we're getting the market index. So the market index refers to the corresponding fCache market, where fCache can be like bought and sold or lent and borrowed, kind of like corresponding to the current date. So this is sort of like a little bit more complicated to explain, but so we won't do it here. But essentially, you may have fCache maturing in 6 months. So for some period of time that's tradable on the 6-month market. But as you get closer to maturity, that fCache may now trade at the 3-month market. And so this get market index will sort of return the proper market based on the time. And then there's some other methods here to go get the token addresses and their sort of precisions and things like that. Yep, and then we will talk a little bit about ETH. So ETH is handled a little bit differently on this wrapped fCache contract than Notional natively. So Notional natively uses ETH like the native token, but the wrapped fCache contract sidesteps that and uses wrapped ETH instead, because that's something that I think is a little bit easier for people to integrate with, since it's just an ERC20 token. So now we'll look at the logic contract. So the logic contract is going to handle a lot of the interaction with Notional, and then the ERC4626 contract is kind of like built on top of this. So most of the meat is here. So we have these two mint via asset and mint via underlying implementations. So mint via asset means transfer C tokens or the asset token into Notional to do the lending, and then underlying will be like transfer DAI to do the lending. So this just gives the caller some optionality based on what token they're holding. Lending via C tokens is going to be like more gas efficient. There's going to be like fewer like kind of hops involved in that, and so some users might opt to do that. So looking at the mint function here, so the non-reentrancy kind of guard is implemented here, so that'll catch any reentrancy coming through here, as well as on the ERC4626 side. Once fCache is matured, critically we cannot sort of like mint more fCache after maturity, so we'll guard against that here immediately. And then what we'll do here is essentially in this if block, we are going to basically do the lending action. So when we're dealing with ETH, there's some special kind of special handling for this. We're going to be transferring wrapped ETH in and then like withdrawing all that wrapped ETH to ETH, and then we're going to call Notional v2 and kind of send it ETH on a payable method. So this encodes like a lend ETH trade and sends it into Notional via this batch balance and trade action. So this is a little bit less gas efficient than this batch lend method, and we'll take a look at that sort of at the end here. But so we won't dive into that here. But in the other case, which is like will be like every other token, we will be transferring from the sender to the wrapped fCash contract. And then calling Notional to then Notional like pull the cash from the wrapped fCash contract to do the lending action. If you're kind of like paying attention here, that's like a couple ERC20 transfers, one from the user to the wrapper contract, and then another transfer from Notional. So it's obviously like not the most gas efficient thing to do here. So we'll talk about how to do this like more directly and eliminate one of those token transfers. At the end here, we'll like mint some tokens to the receiver, and this is I believe so this is going to be the Open Zeppelin kind of like internal mint function, which is going to like update total supply, update the balance, and do a number of checks for the receiver here as well. And then the last method we have here is to send tokens to receiver. So you can take a look at that at the bottom here. So this is used in a number of places throughout the contract, and what this is when you lend fCash, it's because of the way the liquidity curve works, it's very sensitive to changes in time and sort of C token sort of exchange rates that can also change, that also change over time. So it's very common to have some residual amount of like cash left over after lending. And in this case, we'll just send that little residual amount of cash back to the user. So that's what that does. And when we transfer ETH, we always send WETH out. So that's the minting and sending here. So like I said, doing the mint action here through the wrapped fCash contract it's pretty easy. But it's not always the most gas efficient because of those multiple ERC20 hops. So what we also have is we have this hook, which is on ERC777 received. So part of the ERC777 specification is that it calls these hook contracts or hook methods on contracts when you transfer ERC777 tokens. So what a user could do is lend directly on Notional, create a lending position, and then like in the same transaction like transfer that fCash to the wrapper contract here. It's going to be about 20% more gas efficient. And so what we do here is just essentially check that we only receive the matching fCash ID that this contract is willing to receive. So and obviously the caller has to be Notional. So we also do a double check here that we didn't incur any debt through this transfer, and again that like the only assets in the accounts in this contracts portfolio is the matching fCash, and then from there we go ahead and mint. So that covers minting. And then we'll take a look at redemption. So redemption is, in like other terms, is like burning these wrapped fCash tokens. So we'll be like reducing the total supply of wrapped fCash tokens and like deleting your balance. There's a couple of methods here, and there's this kind of like more, I guess like raw method of just like natively redeeming. But redemption, essentially, you're going to specify how many fCash tokens you want to redeem, and then you have a number of options here. of like who you want to receive the fCash. Do you want to transfer the fCash out? That would be like a native ERC777 transfer. And then do you want to redeem that fCash to like the underlying token like DAI, or do you want to receive it as C tokens? And then there's this max implied rate. So this is like a slippage. This is like a slippage limit. So like I said before, when you're redeeming fCash prior to maturity, you're going to be interacting with an AMM on the other side, the notional AMM. You're going to be selling that fCash for cash. So we allow you to set like a slippage parameter there in case there's any sort of like front running or things like that. So looking at the burn implementation here, this is going to override the base level, sort of the internal burn method on the ERC20 contract. So when we do that, we will first actually call that kind of like internal method here, so that this handles like any sort of balance checks, updates the total supply, emits like the correct events and things like that for us. And then what we will do here is we have sort of two, I guess 3 branches inside the redemption, like kind of like the different branches of redemption. So if we have matured, so now we're past maturity, we will first settle the account. So this is sort of like an administrative action. It ensures that the fCash has been like properly converted to like a cash balance, like a C token amount, and then that allows us to kind of run this next interaction here to calculate how much like cash the users owed. So after the first time this happens, this is sort of like a no op, and it'll just kind of like return. So the cash balance here is going to be denominated in C tokens. And so what we'll take is, so if there's 50 million C tokens, what you get a proportional share of the fCash that you're redeeming to the total supply. This is the total supply before we kind of like burnt your tokens here. And then we'll withdraw that cash to your account. So let's take a quick look at that. So what that does is it goes ahead and withdraws like the amount of cash that C tokens that you're redeeming here. And then Notional will like go ahead and like redeem that to underlying if that's required. And then we'll send those tokens to receivers. So that does like a kind of diff on the tokens received here. If the fCash is not matured and you simply want to transfer that, so this is not something probably people are going to do very much, but this is here as kind of like an important option. Like I said at the beginning, when you use the wrapped fCash contract, you lose the ability to borrow against that fCash. So by transferring the fCash back to your contract or back to yourself from the wrapped fCash contract, you'll get it back in your Notional portfolio, and it'll be like sort of immediately like realized as collateral. So so that's what this does. This calls the transfer from, the ERC777 transfer from, and we'll sort of send that fCash. The last option here will be if you're not transferring the fCash and it has matured or has not matured, you're going to be selling the fCash. This is the equivalent to borrowing. Now we're not going to borrow so much that this contract goes into debt. We're only going to be borrowing, like selling the existing balance that it has. So here we're gonna sell that fCash to some. We're gonna sell that fCash. This encodes the kind of action, the borrow trade action that we're gonna do. And then we're gonna call Notional with that, and then send the tokens back to the receiver. So that kind of covers the two primary actions here, like minting and redeeming. Yeah, and note that fCash is denominated in like uint 88 precision, so this kind of guards against any overflow. Now we'll look at the ERC4626 implementation here. So this is sort of a newer standard that's come out for like yield-bearing assets. So this really just builds on top of what's inside the wrapped fCash logic contract. So most of what's kind of like to talk about here is like kind of in these few methods, but we'll go through it all. So the asset token here, now the nomenclature is a little different from Notion nomenclature, but the asset token here, we're going to use the underlying token. So if it's ETH, it'll be WETH, and otherwise we're like DAI, USDC, etc. This is just for simplicity. I think most people are going to be holding those like underlying tokens rather than like the C tokens or what have you. So this is the asset that ERC4626 users will be using to interact with the contract. Now we have two kind of value functions here. One is the matured value, so that'll be like essentially the cash balance. And then the present value here is sort of the net present value of fCash. So we're going to discount that to present value. And these calculations are exposed on the notional side, so we kind of just use those here. Again, so there's sort of like a flip over after maturity between the present value and the matured value here. These convert to shares and convert to assets will, again, sort of do a rough estimate without including slippage of assets to shares. Now, the nomenclature on ERC4626 here, assets will be the underlying token, so the amount of DAI. We call that cash in Notional. And then the shares will be fCash, so the shares of the fCash wrapper. There's these maximum kind of limits here. So, kind of take a look at those, just kind of building off of the different sort of calculation methods that are exposed in Notional for lending and things like that. Lending and borrowing when withdrawing. So, and then deposit and mint are pretty straightforward. We're going to call deposit here. So when deposit, you're specifying assets. We're going to convert that to shares, and then call mint internal. So that's the function we saw earlier. And then withdraw. I think the main special behavior here is that in ERC4626. If a message sender is given allowance, it can sort of withdraw and redeem for an owner. So we're gonna spend the allowance here, and this is a Open Zeppelin function that will kind of check the allowance. Redemption. When interacting with shares, right? Okay. So, with these two methods, with all of these methods, I guess, Notional, Notional truncates transfers at 8 decimal places. So there is going to be some dest amount, on the kind of like the assets transferred. Below that 8 decimal place, below that 8th decimal place, if the token is like DAI with 18 decimal places. So the values here, like there may be some dust in terms of like what's transferred when you withdraw and redeem from Notional. But that sort of covers a lot of the interaction here. The last thing I just kind of want to go over, if you're still watching this, is we're going to talk a little bit about the upgrades on the Notional side that will enable wrapped fCash. So this is not in scope for the Code Arena audit, but I did want to kind of touch on them here. If you're looking at the contracts right now on Notional, like these methods haven't been upgraded in, but they will be for this deployment. So there are 2 pull requests on the Notional Finance like public repository contracts v2. One is an update to the calculation views. So this is basically making these calculations that we already have inside Notional like more user friendly. So instead of like something like kind of opaque here, like that we had before, there's sort of like more friendly names, get fCash, lend from deposit, and then inside Notional we use like different decimal precisions. So this will like do the conversion to like back to like a native token precision, like 18 decimals for DAI, 6 decimals for USDC. So like kind of handle a lot of that for the developer here. So that's upgrade, and these are all view methods. So there's like help developers do calculations against the Notional AMM. We'll also encode these trades for the user and things like that. So they don't have to like re-implement a lot of the Notional like kind of like byte encoding and things like that. So again, this is like improvements to like developer experience. And then we also have this batch lend method. So the batch lend method is this is like a gas efficiency improvement for lending. Like I had mentioned before with lending, there's always the possibility of like dust amounts due to like kind of changes in time, like the sensitivity of the AMM to like time. And so with the normal batch trade action that Notional has, it does sort of like a number of ERC20 token hops and redeems to execute the lending action. It's like pretty gas inefficient, so this is like a significant reduction. Removes at least like 1 C token redemption at the end. It's like about 100k gas, and it works very similar to like how the current batch action, kind of the current trading action works, but it does have this sort of like it only like pulls the amount of cash required to complete the action. And then it does sort of all the checks that the regular trading action does. So there's some adjustment with conversions and off by one handling here. So only lending can occur on this contract, on this method call. And so this is kind of this pull request is on the Notional on the Notional repository as well right now. And then the other improvement we're going to make again to like the developer experience here is C token exchange rates are subject. So C token exchange rates are interesting because you can't get the most current exchange rate through a view method. You have to call a stateful method that sort of like updates the exchange rate and then stores it. So this makes it really difficult for contracts that just want to call a view method to get that C token exchange rate to do the AMM calculations required. So what we're doing here is we're upgrading our sort of aggregation, sort of like our interface with Compound to calculate that exchange rate based on based on the based on some math that's internal to the C token. This is a view method. So internally inside Notional, whenever we do actual stateful changes on the AMM, actual trades on the AMM, currently we always call the stateful sort of the stateful version on Compound, and we get the most accurate C token exchange rate. So this change will only be to view methods and sort of improve these calculations, make these calculations more accurate, kind of irrespective of when the C token has actually accrued its interest rate. So these last two things are obviously way more technical, more in depth, and touch more parts of Notional. So we're leaving them out of scope for the Code Arena audit. But they are here, they're public, and you can take a look. So thanks for watching. This kind of concludes the overview of wrapped fCash. Thanks.